Welcome to IS112 Computer Networks. For this presentation, we'll take a look at how to test fiber. Let's begin. Testing is critical with networking, especially with fiber. In this presentation, we'll go step by step through a sample fiber test. You test fiber to detect problems, example, fiber breaks. For example, you could have a fiber run over telephone poles or underground or between buildings or in buildings, and it could break. Please note that testing fiber requires not only special fiber testing equipment, but additionally specific fiber patch panels and patch cables. You need proper equipment. In this example, we are using Fluke fiber testing equipment. Okay, and that's right here. And one item to note is that you need to have the proper ends hooked up to the tester. The ends that are available are illustrated in the picture above. This is needed so that you can hook up the tester to the specific fiber. And what you'll see, there are a variety of fiber ends. These ends right here that are in this picture are the round ones, and they go with the ST connector. ST is an AT&T trademark. Is probably still the most popular connector for multi-mode networks, fiber. Like most buildings and campuses, it has a bayonet mount and a long cylinder 2.5 ceramic or polymer ferrule to hold the fiber. Most are ceramic, but some are metal or plastic. In this case, these are plastic. A mating adapter is used to make two male connectors shown above. And because STs are spring-loaded, you have to make sure they are seated properly. If you have high loss, reconnect them to see if it makes a difference. Again, these are the ST connectors. This end goes with the SE connector, the square ends. SE is a snap-in connector, also with a 2.5 millimeter ferrule that is widely used for its excellent performance. It was the connector standardized in TIA 56-A, but was not widely used at first because it was twice as expensive as ST. Now that it's only a bit more expensive and much more common. It's a snap-in connector that latches with a simple push-pull motion. It is also available in duplex configuration. This end goes with the LC connectors. Small one with the pinch release. And you see the little release over here. Make sure I highlight this. There's a release over here on these. Small square ones are the LC connectors. This is used for plugging into a transceiver. A transceiver is a fiber module that normally goes into a switch. These are sometimes connected together with plastic, which typically can be removed to plug into the testing equipment one strand at a time. LC is a small form factor that uses 1.25 millimeter ferrule, half the size of the SC. Otherwise, it's a standard ceramic ferrule connector, easily terminated with any adhesive. Good performance, highly favored for single mode. And again, the difference between multi-mode and single mode. Single mode is used for long distances. Multi-mode is used internally, normally to buildings, and single mode has higher throughput. This device is a fluke fiber test that just sends a laser beam. It's class 1 through 8. It picks whichever is appropriate. Be careful, the higher class of laser has dangerous levels of radiation through the fiber, but only accepts an SC connector. The sample fiber tester is mainly for detecting fiber breaks. Very basic tester. This device sends a class 2 visible laser which is used for detecting where a break occurs. This device accepts an SC or ST connector. So again, you're starting to see with the testing equipment, you're limited to what ends does it use. And if you don't have the right ends, you need a patch cable so that you can connect the fiber together. So that's why the patch cables are very important. Here is a common fiber test sample. Please note that in this case there is a device on one end that is a terminator so that the light can be returned to the main test equipment. The device on the left is the terminator and the device on the right is the main test equipment. So you're testing that one strand of fiber from the test equipment through test equipment all the way through all this big wound up amount of fiber to this terminator. Above is a sample reading on the main test equipment on the right. So on the right you'll see a reading. Switch transceiver, see diagram again. Here's the transceiver right here. Make sure I highlight that. These units normally plug right into a switch to connect to fiber. In this case, the testing equipment can't accept the transceiver, then the device can accept appropriate single mode or multi-mode fiber for testing. In this case, the testing equipment does not have a port for a transceiver. Okay. Testing really comes down to having the correct testing equipment and all the different fiber patch cables so that you can test with the ends that your organization has in place. Here's a sample test of a single mode fiber. Note the testing unit has a transceiver in it that hooks up to the single mode fiber. This laser device allows you to select the wavelength with the lambda button or lets you auto-select an appropriate wavelength. It accepts SC connectors. There are so many connectors and different testing needs with fiber. It is much more complicated than testing cat, copper, media. This presentation's focus was to show actual fiber testing. There is never enough testing. Testing prevents future network problems. You have now completed the week 2 part 3 of fiber testing. As always, try to remember to apply what you have learned this week outside of your classroom.